Hey everybody, sorry that I couldn't be at school today. I'm going to try and do this video as quickly as possible. The sub should have handed you a packet for the second part of Unit 3. This would be the first note sheet that's in that packet. I'm just going to run through ways to solve a system of equations. I think lots of you have experience with this, but we're also going to do a little bit on the calculator. So if you don't have your calculator out, why don't you pause the video and grab it really fast. So at the top of the note sheet, the first couple of questions are just asking what a system of equations really is about. First question, what is a system of equations? Two or more equations that describe the relationship between given variables. I think you know that already. What are you finding when you solve a system of equations? You're finding the set of solutions that are common to both equations. So what values for the variable would be solutions to both equations, which can also be seen when you look at a graph. Remember, graphs are just sets of solutions to equations, so where the graphs intersect each other is also where the common solutions are. There's many different ways to solve a system of equations. We're going to start with the graphing. We're going to do one by hand, but graphing by hand isn't really always a great method because the solutions might be fractional decimal things that you wouldn't necessarily be able to tell graphing by hand. But the one we're looking at right now ends up being an integer, so we're just going to refresh our memory here about graphing and solving. Now this first equation right here is in standard form. Technically, to just get a graph of it, we wouldn't need to change it, but I want to make sure that I get this as accurately as possible. So I'm going to change this into slope-intercept form. So doing this and then dividing by -2. So in slope-intercept form, this is going to be the equation 2x minus 9. So y-intercept is 9, up 2 over 1, and I am going to keep going up 2 over 1 through the whole graph just to be sure that I've got my line as accurate as possible. I don't know exactly where the intersection is going to be. All right, for the next one's in point slope, and I think I can get this pretty accurately just by plotting the point 7, -5, and then using the slope to be -1/2. So 7, -5 is here. Slope being -1/2, I can go down 1 over 2. Ran into the edge of the graph, so I'm going to go up 1, back 2, and there's the intersection right there. So I'm really not going to need to do any more points. The place where they cross each other then is that point right there at 3, -3. And if you were to take x equals 3 and y equals -3 and plug them into both equations, they would be a solution to both. All right, now I want to show you how to do this on your calculator. So we're actually going to use exactly the same equations. We already know what the intersection is, so this isn't really about finding the answer. This is about how to use your calculator. Now, one thing that's really, really important when you use your calculator is that everything needs to be solved for y. It doesn't necessarily have to be in any specific form. It just has to have y on one side by itself. So this first equation, we already solved this for y. So that was 2x minus 9 from above. And then this one, if I solve it for y, I can get y alone just by subtracting 5 over to the right side of the equation. So I'm not even going to worry about distributing that -1/2. It does not matter. All right, so on your calculator, let me find the calculator for you right there. You will see, here's your opening screen, right? You don't have a 5 there. If you've never used this before, then take a look at the top left corner. You see a button that says y equals. It's up here. Go ahead and hit that button. Your calculator can hold up to 10 equations. Generally, we only use two at a time, but there may be other times where we would need more. Oops, don't go that high. So I'm going to put these equations in here. Now this is why you had to have them solved for y, because all of these are y equals. I'm going to put in 2x minus 9. 2 obviously is here. If you've never used this before, be careful about how you get your x. This is not an alpha x. Take a look up here where you see the little cursor. There's a button that says x, t, the symbol is a theta, and then an n. Hit that button to get your variable. So 2x minus 9. And then the next equation was -1/2, which you can just, got too many ones in there, -1/2, which you can put just like that, and then in parentheses, we had x minus 7. Remember to use this key up here for your x. And then I've already forgotten, was that -5? Let's see. Yep, -5. All right. And when you go to hit graph, if you're not seeing this screen right here, your screen, you may have made it a different size. You can always get back to a 10 by 10 screen. Do you see where the zoom button is, top middle? Hit zoom. Standard is number 6. So if you hit zoom and then hit 6, it will take you back to the screen so that we're all looking at the same thing. Okay, where do you go to find an intersection of graphs? Do you see up here again at the top, lots of good stuff here, there's a button that says trace. Now we don't want trace, but above it, it says calc. There is a menu that does lots of calculations on the graph, and we'll use this quite a bit. To get to it, you have to hit second trace, and you will see this menu. Obviously, we want to find an intersection, which is number 5, so you can either scroll down or you can just hit 5. Your calculator is now going to ask you some questions which seem silly. We're just going to kind of hit enter through them right now, but I want to explain what these questions are asking. It says first curve at the bottom. Don't be thrown off by the word curve. It still applies to lines. It sort of means first equation. And you'll see what equation they're talking about at the top. 2x minus 9. Now, why is your calculator asking you this? Because remember, technically your calculator can hold up to 10 different equations, but you can only find the intersection of 2 at a time. So it's asking you these questions because potentially you could have more than just 2 equations. We only have 2 in there, so we don't have to worry about these questions. First curve, I'm just going to hit enter. It automatically bumps to the second equation, which was the -1/2 times x minus 5. I'm sorry, x minus 7, and then -5. You can just hit enter again. And now a guess. Lines can only intersect at most in one place, so it's not like there's a lot of options. But we're not just always going to be finding the intersection of lines. We're going to be finding intersections with other things where there could be more than one intersection. And your calculator can't find all intersections. It can only find one at a time. So I'm just going to put this close, and then it's really important that you make sure and hit enter a third time. If you don't hit enter when it says guess at the bottom, then you're not actually getting the intersection point. So there it says intersection 3, -3, which is what we already knew, but this was just about the calculator keystrokes. All right, so let's give this a try with a different one. So again, that was 3, -3. Number 3, I'm going to do this one with you just because something kind of creeps up in this one that you may not have done yet. Again, I need to solve both of these for y. So for the bottom one, I'm going to add 10 to the other side. For this one, I'm going to divide everything by 3. So this will be 3x minus 3. All right, so go back to your calculator. I'm going to go back to y equals. I'm going to clear these 2 out. And I'm going to find an intersection here, 3x. Remember which button you're using there for the x. 3x minus 3, and then x plus 10. So the reason I wanted to do this one with you instead of letting you do it is because when you go to hit graph, you don't even see the intersection on there. I can anticipate the intersection is up here a little bit higher. You're not going to be able to find the intersection always if it's not on the screen. So I just want to show you another calculator feature. Do you see where it says window? Window is how big the screen is. When we did a zoom 6, it took us to a 10 by 10 screen. I kind of want to see a little bit higher up because that's where it's going to be intersecting. So I'm going to go down to my Y max and I'm going to make it something bigger. And then I'm going to see again, did I capture the intersection point or did I not capture the intersection point? All right, so now I do see the intersection point right there, so I can go through the same steps as before. So again, I'm going to hit second trace to get this menu, the calculate menu. I'm going to select intersect. The calculator is going to ask me some questions. First curve, I only have 2 equations in there, so I can just hit enter and enter. And there's only one intersection point, so you could hit enter just a third time. I always like to put it a little bit closer. And there we go. The intersection, you don't have the answer until it says intersection at the bottom, is 6.5, comma 16.5. So we'll go back here and jot that down. The intersection, oops, not sure why I just did that. Hang on here. Get rid of that. There we go. Sorry, didn't mean to take so long to figure that out. All right, go ahead and pause the video, and I want you to try question number 4. Okay, what you would have seen when you went to graph this is that there are parallel lines. There is no solution to this. And maybe you would have realized that when you went to solve the bottom one for y, you'd realize that they actually have the same slope. So there is no solution because those are parallel lines. All right, so let's take a look at some of the vocabulary that goes along with a system of equations. And this might be new information to you, but we talk about systems that are consistent and systems that are inconsistent. An inconsistent system is like what we just had. There is no solution to an inconsistent system. A consistent system, which I know is hard to say pretty fast, right, has a solution. So in the ones that we just finished, number 3 would be considered consistent because there's a solution, and number 4 would be considered inconsistent. There's another way to describe them. Once you realize that a system does have a solution, then we are going to define them by being either independent or dependent. So, clearly I'm having trouble with my pen today. We'll just switch colors here. So independent is when there is one solution, one intersection point. A dependent system is when there are an infinite number of solutions. Now, some of you might remember what that means. An infinite number of solutions is when the 2 lines are actually the same thing. They're right on top of each other, and every single solution is a solution. All right, there were 2 methods for solving systems. I'm going to do these pretty quickly. The first one is substitution. Substitution involves solving one of the equations for a variable, like in number 5, that's already solved for y, and then taking that and substituting it in place of y in the other equation. So 3x plus 2 times negative x plus 3 equals 5, and then we're going to solve this for x. So this will be negative 2x plus 6. I've got x plus 6 equals 5. So x is equal to negative 1, but remember that's only half the solution. I still need to plug that back into one of the equations and solve it for the other variable. So y is 4. So the solution to this equation is, the system of equations, is negative 1, 4. The other method for solving is called elimination. Some books actually call it linear combinations. I'm not sure what you may have heard it called before. But the goal of elimination is to get opposite numbers either on x or on y by multiplying the equations by a constant. So in this one, let's say I wanted to get rid of the y first. Right now, I have 2 and I have 5. 2 and 5 both go into 10, so I'm going to multiply both equations by a constant number so that one of these is positive 10, one of these is negative 10. So I'm going to take the first equation and I'm going to multiply everything by negative 5. So that's going to give me negative 15x minus 10y equals 45. The bottom one, I'm going to get this to be a positive 10, so I'm going to multiply everything in the bottom one by positive 2. So this will be this is going to be negative 20x plus 10y equals negative 10. And then the goal here is to eliminate y by adding them together. So if I add down, those cancel. This becomes negative 35x equals 35. X is equal to negative 1. And then just like before, you still have to solve for y. So I'm going to go back to the top equation, and I'm going to plug negative 1 in for x. So plus 2y equals negative 9, and then solve this really quickly for y. 2y equals negative 6. So y is equal to negative 3. So the solution to this is negative 1, negative 3. Okay, go ahead and pause your video for just a second and give numbers 7 and 8 a try. All right, I threw you a couple of curveballs, huh? So number 7, the decimals that are there, you can just get rid of those in the beginning and that would be fine. So multiply the top by 10 to get rid of the decimals, multiply the bottom one by 100 to get rid of the decimals. And then what you find with this one is you end up with something 0 equals 0. And this is a situation where there are an infinite number of solutions. This is one where they are exactly the same line, so they have all the intersection points. You don't want to write the answer as all real numbers because we can't just randomly pick any numbers and it will work. They still have to be on that line. So rather we would say that there are an infinite number of solutions. Number 8 was a little tricky just because of the fractions, but if you look at the y's, the coefficient of the top y is 1/3 and the coefficient of the bottom y is negative 2/3. So I just multiplied the top by 2 so that I would have negative 2/3 y and positive 2/3 y. And then when you go through and solve that, you end up with the ordered pair 10, 6. All right, last two questions. Go ahead and pause the video for just a second and solve those two systems. All right, go ahead and check your answers. Now the last page of your note sheet is an applications page. I'm not going to talk you through that in the video because I think the video is getting kind of long. So I'm going to fill it out and I'm going to put it into the note sheet folder on Canvas so you can give those a try and then take a look at the solutions on Canvas. All right, I will see you all tomorrow.